In this video, we're going over the 4 physics perspectives. The question asks, a 220-gram rock is thrown straight up into the air with a speed of 10 meters per second. Determine the following. So the question will ask us to look at the question with a kinematics perspective, a force perspective, a work perspective, and influence momentum perspective. So those are the 4 perspectives. Okay, so starting off with kinematics, the diagram will be a rock that is 220 grams is thrown straight up with a velocity of 10 meters per second. So we're trying to find the maximum height from the release point. The maximum height is d. Okay, so we would need to find an equation that would best suit this question. So finding max height. So we have acceleration and no, we don't have acceleration. We have initial velocity and we have the mass of the rock. So which equation right here would best suit the question? So it would not be this equation or this equation because they both have time and we're not given time. The only equation that's not given time is this equation. Okay. So this equation is v final squared equals v initial squared plus 2ad. And d in the equation was written as x final minus x initial. Okay. So v final, since we're looking at the maximum height, v final would be 0 because when you throw the rock up, it goes 0, velocity is 0 before it goes down. So up and then 0, down. Okay. So we would get 0 is equal to v initial squared plus 2ad. Okay. So since we're looking for the maximum height, that's d, you subtract v initial squared to the other side, or 2a is equal to d. So plugging in the values, d is equal to negative v initial squared over 2a. D is equal to negative 10 squared over 2, 9.8. And using a calculator, we will get 100 divided by 2, 1.8. So your final distance would be 5.1 meters. Okay, moving on to part B. Use Newton's second law to determine the free fall acceleration of the rock. Newton's second law is F equals ma. Force equals mass times acceleration. So we're looking for the acceleration of the rock. So let's try FBD for force. Since you're throwing a rock in the air, so the rock is in the air, and it could be either moving up or moving down. It doesn't matter for this question. The only force of gravity exerted right here is force of gravity, Fg. There is no force of friction because we're currently assuming all friction is negligible and there is no external force aside for force of gravity. So F net is just force of gravity. So Fg is equal to ma. So Fg Fg is equal to mg. So mg is equal to ma. So m cancels out. So a is equal to g. Moving on to part C. Use wet to determine how high the rock goes. So the work energy theorem is work net is equal to delta K. And delta K is kinetic energy. So the work net, all the work that is done onto the object is just the force of gravity. So Fg. And the equation for work, and this is work is equal to Fd cosine phi. And cosine phi is just equal to 1 because this is your FBD. The force of gravity is pointing down, and phi is the direction of motion. And let's say the rock is moving down along, so phi is equal to 0 or 180, and cosine 0 or 180 is equal to 1. So 0 or 180. So this is equal to 1. So work is equal to FD. So substituting this in, F, and F which is Fg, times D cosine phi 1 equal to kinetic energy, the delta of kinetic energy. So delta is Ke final minus Ke initial. K final minus K initial. And the formula for kinetic energy is 1/2 mv squared. So K final, K initial is equal to 1/2 mv squared. And you gotta plug in the final and initial respectively. So Fg D is equal to 1/2 mv final squared minus 1/2 mv initial squared. So we know that the v final is equal to 0 because as you get on the top of the free fall, it is equal to 0. So Fg D is equal to negative 1/2 mv initial squared. Okay, so Fg is equal to mg. Mg D is equal to negative 1/2 mv initial squared. The m on both sides cancel out. So force of gravity times the distance is equal to negative 1/2 mv squared, not m. 1/2 v initial squared. So D is equal to negative 1/2 v initial squared. Yeah, just like that. Okay, so plugging in values, D is equal to negative 10 squared over 2, negative 1.8, which is the same equation we got for the kinematics perspective. So yeah. So this is the same equation, and you would get 5.81 meters. Okay, finally, looking at part D, the impulse momentum perspective, we're determining how high the rock goes. So the formula for impulse momentum is J net is equal to delta P, and delta P is P final minus P initial. And J net is just the impulse of force of gravity. And the equation for that is J, force of gravity, is equal to F times delta t. So substituting these in, F delta t is equal to momentum final minus momentum initial. And the formula for momentum is mv, and substituting final and initial respectively. So force of gravity is equal to mg delta t is equal to mv final minus mv initial. Since v final is 0, this all goes to 0. So mg delta t is equal to negative mv initial. And both sides can cancel out. G delta t is equal to negative v initial. Okay, so here might get a little tricky because you're solving for t time. To solve for t, you have to use a special kinematics equation that's not in the formula sheet. So it'd be d is equal to 1/2 v initial plus v final t. But you can derive it from other equations. Okay, so now in order to solve t, you use some simple algebraic steps. So multiply 2 both sides, then divide by v initial plus v final is equal to t. So plugging it back in, we get g 2d over v final plus v initial plus v final negative v initial v over v naught. Okay, so you gotta use some algebraic manipulation again to solve for d. So v final is 0. Multiply g to the other side, and divide g to the other side. 2d is equal to negative v initial squared because this v initial divided by g, and d is equal to negative v initial squared to g. And realize that how you're able to get the same equation from different perspectives. So this question really shows you how you can solve the same question with multiple physics perspectives. And I hope you are able to understand that you're able to, but you just use different methods.